Our authoring tool for CIS 660 is called FLUD, which stands for Faster Liquids Using Divisions. Here is a picture of the final rendering result. Fluid simulation has been widely used in films and games. Our tool can help the artist produce resolution-divided, realistic, and detailed fluid simulation quickly. Following are the features of our tool. Users can designate fluid container size, number of particles, geometric boundary region, and particle resolution level. Fluid within the boundary region will have higher resolution. Our tool can also automatically transfer the fluid data to SPH framework and create fully animated particle fluid in Maya. It can generate n-particle system, which can be easily converted to polygon mesh for high-quality rendering. Our tool is based on a paper called Two-Scale Particle Simulation by Solenthaler and Marcus Gross. The main steps of the algorithm are as following. First, the user needs to specify boundary region by using our GUI, and then the boundary data will be transferred to SPH framework. The simulation will run, and particle position information is saved to a text file for every frame. After that, text file is read by Maya and n-particle system is created. And each particle is bound to a locator, which is keyframed to the appropriate position. Here is a short animation shows the main idea of two-scale particle simulation method. The high-resolution particles will be created when a particle enters the boundary area based on resolution level input, and it will be deleted if they leave the boundary area.
FLUD was implemented based on an open-source SPH simulation system called FLUIDS. FLUIDS provides an OpenGL interface which we used for testing our two-scale boundary detection algorithm. We changed multiple core components of the FLUID system, including modifying the main data structure and adding the algorithm for addition and deletion of particles within the boundary region. The necessary functions of the simulation framework were compiled into a DLL and are accessed by the FLUD plugin using the Maya API. Finally, we used MEL scripting to construct the GUI, input the fluid data files, set up our scene, and keyframe the particles. Here's an example from the FLUIDS framework of a 100-particle simulation with no subdivision on the left and an 8-time subdivision on the right. Here is a demo of FLUD in action. We start by opening the GUI window, which creates the fluid container and boundary region objects. These can be modified either through the GUI or Maya's Move and Scale tools. We then adjust the number of particles and set the desired resolution level. Finally, we change the time slider to set the simulation length. When we click Create, the particles are generated within the FLUIDS framework, and their position data is transferred to Maya and keyframed at each time step. After generation is complete, we can step through the entire simulation in Maya. The system is now ready for rendering. After the particle simulation is set up in Maya, it can easily be converted to a polygon mesh. Standard materials and rendering techniques can then be applied to produce high-quality images. We now present final rendered sequences based on a 100-particle simulation. The system on the left contains no additional particles, while an 8-time subdivision is present on the right, producing between 500 and 800 high-resolution particles in the boundary region.